A very happy and a warm good morning to you all children. Hope you are all keeping yourself fit and you are enjoying your online classes every day. Children, today we are going to see a new lesson called motion. What is motion? Any object which moves from a distance or for a distance, we say the body is in motion. Or when the position of an object changes, then we say it is under motion. In everyday life, we see many objects around us. For example, when you come out of your house, you see your house and you can see the trees. Also, you can see some people walking here and there, and some people going in a motorbike, car, etc. These things which you see around you can be classified as objects at rest and objects in motion. Those objects which keep their position stationary or they don't change their position, we call it as they are at rest. So objects which do not change their position, we call them as they are at rest. But when the object keeps changing its position, then we call it as motion. For example, those who are walking, those who are going in a motorbike, and those who are going in car. So we see there is a distance covered by them when the time goes on. So this is what is called motion. And also we see many things around us in our day-to-day life. When we see the fish in the aquarium, we see it's at random motion. Not only the objects that we are seeing, even the heavenly bodies, as you all know, they are under motion. So you know that the earth is revolving around the sun and the planets, all of them are revolving around the sun. So they exhibit motion. This rest and motion are the two physical quantities which are interrelated. An object which is at rest for one person seems to be under motion for others. For example, if you are sitting in the bus and if you look at the window, for you can see the various objects like trees, the pole post, they move in the opposite direction of you. So according to this, you are under motion. But for a passenger who is sitting next to you, he observes you are not at all moving. So what is rest and what is motion? Here comes the confusion. So in order to get clear about all this and to enhance the various subtopics like speed, velocity, acceleration, and graphical representation of these motions, we will explain in this lesson. And so it requires a lot of your concentration to understand the concepts. Therefore, children, please listen to the slides and get the things known. Right? So we will now go into rest and motion. These are the two important terms in physics which you must know. If a body is at stationary, that means it doesn't move, then we say that the object is at rest. So look at the examples which are given in the slide for objects which are at rest. The house, the tree, and a post. These are fixed. they are stationary, they cannot move. So these objects are at rest. So in short, we can say an object is at rest if it doesn't change its position. If the position is not changed, then they are at rest. Obviously, when there is a change in the position of the object, then we say those objects are under motion. For example, look at that boy. He is kicking the football. So the position of the ball changes. So the ball is in motion. The same time, the bird flies. So when they fly, they change their position. So the bird is under motion. So those objects which change their position with respect to the surrounding or with respect to time, then they are said to be in motion. So we have two reference points here with respect to position and with respect to time. So when the ball moves, definitely it will take some time. When the bird flies, it will also take definitely some time. So when a body is under motion, it can be referred to the position as well as the time. So the objects which change their position with respect to their surrounding or with respect to time, then it is said to be in motion. Now imagine the situation which I am going to tell you now. You are standing on a railway station platform. So on the railway station platform, you see many things around you. A shop, the person sitting near to you, then maybe a train which is in front of you, which is not moving. So these objects where I referred, the shops, the person next to you who is sitting, and the stationary train, these objects are at rest when you are the referral point for you. It is these objects are at rest. Now imagine the train in front of you starts moving. Now what can you say? The train is now in motion. Why? It changes its position from time to time. So as the time goes on, the train starts moving faster and faster. So the train which is in front of you becomes now the train is in motion. And now for a person or for a passenger who is sitting inside a train or a bus, is he under rest or he is in motion? Now you can tell that when the person is inside the train or a bus, he is also under motion, because when the passenger looks outside, whatever he sees, the trees, the pole post, the buildings, they seem to move. Therefore, the passengers, when they are in moving train, they are also said to be in motion. We have seen that a body is in motion when it changes its position. So when it changes a position, there must be some distance covered by the object. So the distance is basically the actual distance traveled by the body. And there is another word which is equivalent to distance, which is displacement. Then how is displacement different from distance? So what is distance? It is the actual distance traveled by the body. And what is displacement? Displacement is the shortest distance between the initial and the final point. So in order to understand the distance and displacement, I have given you an example. Look at the slide, the figure A. There is a tree. Figure B, there is a house, and the distance between the figure A and figure B is 4 meters. And there is another figure which is a tree C, and the distance between the house B and the tree C is 3 meters. Now let us, for example, a cyclist is traveling from A, then reaching the point B, and then reaching the point C. So how much is the distance traveled by this cyclist? So as per the diagram, from A he is going to be 4 meters, and from B he is going to C, again 3 meters. Therefore the total distance traveled by him is 4 plus 3, 7 meters. So the actual distance covered by the cyclist in reaching the point from A to C by traveling through the point B is 7 meters. Now, what is the displacement of this cyclist? The displacement of the cyclist, so what is the initial point? The tree A. What is the final point? The tree C. And what is the distance between A to C? So initial point and the final point, that becomes the displacement. Now when you calculate using Pythagoras theorem, the right angle triangle here, then the hypotenuse becomes 5 meters. So that means this is the displacement. The displacement for the cyclist is 5 meters. That is the shortest distance from A to C. That becomes the displacement. Now come back to the definitions. What is distance? Distance is the actual distance traveled by the body. So 4 plus 3, 7 meters. And what is displacement? It is the shortest distance between the initial point and the final point. So here the displacement becomes 5 meters. Okay. Now distance and displacement are entirely two different terms. Distance is a scalar quantity and displacement is a vector quantity. Here we see a slide which gives you the difference between distance and displacement. It's an important question for the board. There are totally 4 differences between distance and displacement. Let us look into it one by one. Length of actual path traveled by an object is called the distance. The shortest length between the initial and the final position of an object is known as its displacement. Second point, it is a scalar quantity. Distance is a scalar quantity. Displacement is a vector quantity. What is a scalar? A scalar will have only magnitude. What is magnitude? Just a number. For example, if I say I bought 2 kilograms of potatoes, then the 2 kilograms becomes the magnitude. So magnitude is a number. 2 kilograms is the magnitude here. So distance, I walk 2 meters. The 2 meters is the scalar because it has only magnitude. And displacement is a vector quantity. A vector quantity will have direction along with the magnitude. So those quantities which have magnitude and direction, they are said to be the vector quantities. Now if I say the car travels at 60 kilometers per hour from Salem to Bangalore. So here you have the magnitude 60 kilometers and you have the direction, that the direction is from Salem to Bangalore. So it is a vector. So scalar quantities has only magnitude, just a number. Vector quantities has magnitude as well as direction. So distance is a scalar quantity and displacement is a vector quantities. Third point, distance can be positive, can't be zero or can't be negative. Distance has only positive magnitude. It cannot be zero and it cannot be even negative. But displacement can be positive, can be negative, or even it can be zero. Most wonderful, right? So you will come across this in the examples which we are going to see further. So displacement can be positive, negative, as well as it can even be zero. Now let us sum up what we have dealt so far. Go through the slide each point by point. Motion. A body is said to be in motion when its position changes continuously with respect to a stationary object taken as a reference point. Example, when the position changes of a car continuously with respect to a stationary object like house and trees, etc., we say that the car is in motion. Distance travelled and displacement. Distance. The distance travelled by a body is the actual length of the path covered by the moving body, irrespective of the direction in which the body travels. Displacement. When a body moves from one point to another, the distance travelled refers to the actual length of the indirect path, whereas the displacement refers to the straight line path between the initial and the final positions. Distance is a scalar quantity because it has only magnitude. It has no specific direction. Displacement is a vector quantity because it has magnitude as well as direction. Distance travelled by the moving body cannot be zero, but the final displacement of a moving body can be zero. The displacement of a moving body will be zero if after travelling a certain distance, the moving body finally comes back to its starting point. So when a body comes back travelling to the same starting point, then the displacement is zero. Look at this slide where distance and displacement are being calculated. Now let us take the first figure. A is the starting point and B is the finishing point. Obviously, A and B both becomes one and the same. So, what is the distance travelled by him? In travelling the distance, first he takes up 3 meters, then 2 meters, then 3 meters and 2 meters. The figure is like a rectangle, so the perimeter of this rectangle becomes the distance travelled. So 3 plus 2 plus 3 plus 2. So the total distance travelled by him is 10 meters. And since the starting point and the finishing point becomes one and the same, here the displacement becomes 0. Right? Now look at the right side figure. So A is the starting point, B is the finishing point. So what is the total distance traveled by him? It is, he is walking or traveling 10 meters plus 5 meters plus 10 meters. So 10 plus 5 plus 5, it becomes 25. So the distance traveled from A to B is 25. And what is displacement? The shortest distance between starting point A and the finishing point B. So how much is the distance between A to B? So you know that in a rectangle, the opposite sides are equal. Therefore, 5 meters. The distance between A to B is 5 meters, and that becomes the displacement here. So you can now understand that distance and displacement are entirely two different quantities where the values are changing according to the positions. Children, you may be wondering why this slide is kept empty. So it is you to fill it up. You have to solve this question on the distance and displacement for a circular problems. So the problem says an athlete completes one round of a circular track of diameter 200 meters in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes and 20 seconds? So this is a question for you. Now it is a circular track, and what is the information given to you? That 200 meters, that is the distance traveled for one complete round is 200 meters, and he is completing it in 40 seconds. So one round can be completed in 40 seconds, and when he completes one round, he is covering a distance of 200 meters. So after 2 minutes and 20 seconds, how much is the total distance traveled by him, and what will be the displacement? So try to complete the problem, solve the problem. I will send you the answer after 12 or 1. Okay, children? Now we are going to learn about uniform and non-uniform motion. We have seen about motion. Any body changes its position with respect to time, then we call it as motion. Motion can be classified as two types, uniform motion and non-uniform motion. Now in the slide you are being given with two examples, car A and car B. Now look at the tabular column below or besides the car A. Time in seconds and distance covered in meters. So in 0 seconds it is in 0 meters. In 5 seconds it is 10 meters. 10 seconds 20 meters. 15 seconds 30 meters. So it goes on like this. Now analyze the data given here. Now the time, it is of intervals 5 seconds. See, 0, 5, 10, 15. So it is increasing in 5 seconds. Now similarly, analyze the distance given here. 0, 10, 20, 30, 40. So it is also increasing in steps of 10 meters. So for every 5 seconds, it travels 10 meters. So this is known as uniform motion. When a body travels equal distance in equal intervals of time, it is known as uniform motion. Here the uniform time is 5, so the time is increasing every 5 seconds, and now look at the car B. Now see to the time 0, 5, 10, 15, 20. So the time is uniformly increasing. There is a time interval of 5 seconds between the first and the second. Now see to the distance 0, 5, 5 to 15, 15 to 20, 20 to 30. So the distance here, they are not covering equal distance. So between 0 to 5, the distance traveled is 5. Between 5 to 10 seconds, the distance traveled is from 5 to 15. So here the distance traveled is 10 meters, whereas in the earlier case it was 5 meters. So unequal distance are covered in equal intervals of time. So it is an example for non-uniform motion. Here the part B does not cover equal distance in equal intervals of time. Therefore, it is in non-uniform motion. So in short, we say if a body covers equal distance in equal intervals of time, it is traveling with uniform motion. Or else, if the body covers unequal distance in equal intervals of time, then the motion is the above learned uniform motion and non-uniform motion can be represented in the form of a graph. Now before that, let us recall uniform and non-uniform motion. Uniform motion, a body has uniform motion if it travels equal distance in equal intervals of time, no matter how small these time intervals may be. The distance time graph for uniform motion is a straight line. So you see to the graph, x-axis and y-axis, in time is taken in x-axis and distance is taken in y-axis. And see to the line, it is a perfect straight line. So if you get a graph like this, then the graph indicates that the body is traveling with uniform motion. For non-uniform motion, what is the definition? A body has non-uniform motion if it travels unequal distance in equal intervals of time. So for this, the graph will not be a straight line, the graph will be a curved line. So the same physical quantities are taken in the graph, that is time in x-axis and distance in y-axis. So the graph for non-uniform motion will be a curve. So if a graph is given with a straight line, it indicates the body is traveling with uniform motion. And if it is a curved line, then it represents the body is traveling with non-uniform motion. Now let us discuss about the important term in physics, speed. What is speed? Speed of a body is the distance traveled by it in unit time. Unit time, what does unit mean? Unit means single, 1 second, 1 hour. So if we represent like this, then it is unit time. So the speed of a body is defined as the distance traveled by it in unit time. So the formula goes according to the definition like this: speed is equal to distance divided by time. For example, if a boy covers 100 meters in 10 seconds, then what is his speed? So the distance covered is 100 meters, time in 10 seconds, so 100 divided by 10, it's equal to 10. Now speed has a unit. Usually we measure all the quantities in SI unit. So the SI unit of distance is meters and time is in seconds. So the SI unit for speed is meter per second. So the SI unit goes hand in hand with the formula distance divided by time, distance in meter divided by time, time in seconds. So meter per second is the SI unit of speed. So whenever kilometer, the distance is expressed in kilometers, then you have to convert it into meters. Similarly, if the time is given in minutes or hour, then you have to convert it to seconds for doing your calculations. So, let us sum up. Speed of a body is the distance travelled by a body in unit time. The formula says speed equal to distance divided by time, and its SI unit is meter per seconds. And we keep some letters in physics, especially this lesson, for many physical quantities. So here in this slide, speed is expressed in as V. Distance is always kept by the letter S, and time is always expressed by the letter T. So the formula V is equal to S by T. So don't confuse for S as speed. S is the distance travelled. So wherever distance are there, we express it with the letter S. S is not for speed. Please do remember this. Therefore, V is equal to S by T, where V stands for speed, S stands for distance, and T stands for time. Okay. This slide gives you the triangular formula to calculate or to remember easily the formula for speed and hence the formula for distance and time. As I have told you in the previous slide, S is kept for distance, but here S is kept for speed. So see to the triangle DST, where D represents distance, T for time, S for speed. In order to make you to understand easily, these letters are being taken here. So in the first slide, S is being blocked with blue color. That means close S. If you close S, you are getting the formula for S. So speed is equal to, you have in the numerator distance and in the denominator time. Therefore, speed is equal to distance by time. Now in the second triangle, the letter D is being blocked. So if you close D, then what is the remaining letters that you find? S and followed by T. So speed into time will give you distance. And in the third, T is being blocked. That means it helps you to find out the formula for time. So when you block T, you find D up and S down. That means distance divided by speed. So this is a triangular formula which when you remember, you can recall all the formulas whenever you are doing problems. So this is what is called speed triangle formula. And on the right you find average speed. So if you are asked to calculate average speed, then do the total distance, then divided by the total time. Total distance divided by total time will give you average speed. So here, after you get familiarized with this, replace this triangle with your own letters. That is, speed is V, distance is S, time is T. So with this you get practiced. So this I have given to you with these letters because in order to make you to learn easily. This slide, as we have explained to you, gives the formula for average speed. When average speed is being required, for example, I am starting from Salem and I am going to Dharmaburi. So I first go with a speed of 60 km per hour. Then I take a break in between. Then I continue my journey with 80 kilometers per hour. Okay, now here comes the average speed. So average speed comes whenever there is a break in the journey. When there is a break in the journey, there is a break in the time, there is a break in the distance, and hence this break in the speed. So in this case, the average speed has to be taken. So how to calculate the average speed? The total distance. So the distance remains the same. You cannot make it enlarged or diminished. So the distance, total distance traveled and divided by the total time taken. So this will give you the average speed for an object. Children, now let us have a look on uniform and non-uniform speed. Do you recall the same thing we have studied previously? That was for uniform motion and non-uniform motion. If you recall, if a body covers equal distance in equal intervals of time, then that motion is referred as uniform motion. If the body has covered unequal distance in equal intervals of time, then that motion is referred as non-uniform motion. So, the word uniform and non-uniform even comes in speed. So, uniform speed and non-uniform speed. So, we have already seen what is speed. Speed is the distance covered by an object in unit time. Now, what is uniform speed then? If the body covers a fixed distance in each unit of time, the motion is known as uniform motion or uniform speed. So the body has to travel. The motorcyclist, you see, for every 5 meters, it takes only 1 second to cross it. Okay, the distance is uniform, the time is also uniform. When the distance and time are uniform, then the speed, which is calculated as distance traveled divided by time, so that also becomes uniform. So he covers equal distance in equal intervals of time. So the motion becomes uniform motion. When the motion becomes uniform motion, the speed also becomes uniform because distance traveled by time. So 5 divided by 1 is equal to 5 meter per second. So for every gap, it travels with a speed of 5 meter per second, 5 meter per second, 5 meter per second, and hence till he completes his journey. Therefore, here the speed is uniform. Then what is non-uniform speed? If an object does not cover a fixed distance in each unit of time, the motion is known as non-uniform motion or non-uniform speed. For example, the same motorcyclist, for the first slot he covers 5 meters, then for the second slot if he covers 8 meters, for the third slot if he covers 6 meters, and the next slot he covers it for 3 meters for every second, then the motion becomes non-uniform motion because he is covering unequal distance in equal intervals of time. The distance is not uniform. Therefore, here the motion is not uniform. When the motion is not uniform, the speed obviously is not uniform. So we have uniform speed and non-uniform speed as we have it for motion also. Here we are taking up a problem with the speed, that too with average speed. See to the question. A car travels 85 km from point A to B, then 45 km from point B to C. So he is traveling from the point A to C by crossing the point B in between. So the distance AB is 85 and the distance BC is 45. The total time took was 1.3 hours. So what was the average speed of the car? So as we have discussed earlier, the average speed is calculated by the formula total distance divided by total time. So the total distance, you will get it when you add 85 with 45. So 85 and 45 will give you 130 kilometers. So the total time taken for this journey is 1.3 hours. So average speed is equal to 130. So according to the formula, total distance divided by total time. So 130 kilometers divided by 1.3 hours. So you get 100 kilometers per hour. So the average speed for this person is 100 kilometers per hour. Speed can be expressed in kilometer per hour, or it can be expressed in meter per seconds. When both of them are given in the same hours and kilometers, you can express it in kilometers per hour. If the distance is given in meters and time in seconds, you can express the speed in meter per seconds. When the distance is given in kilometer and the time is given in seconds, then the kilometer has to be converted into meters. Then you have to do the problem. Okay, children? So get practice. I will give you more problems to solve yourself at the end of this lesson. Children, the next physical quantity that we are going to learn is velocity. Velocity is nothing but it represents speed. Then why do we have two different terms, speed and velocity, when they are one and the same? The only difference between speed and velocity is speed is a scalar quantity and velocity is a vector quantity. Already we have discussed what is a scalar and what is a vector. Scalars will have only magnitude. Magnitude means just a number. And vectors are the one which will have, along with the magnitude, direction. So when you have only magnitude, it is called speed. When you have magnitude and direction, we call it as velocity. That is the only difference. Everything, the formula, the unit, everything remains the same, excepting speed is scalar and velocity is vector. How can we define velocity? The quantity which specifies both direction of motion and speed is velocity. Velocity of a body is the displacement of the body per unit time, because velocity, as I told you, is a vector. So displacement here is also vector. So vector has to be referred for vector. So velocity is equal to the formula takes up, instead of distance, displacement divided by time taken. Since velocity has both magnitude and direction, it is a vector quantity. So what is the formula for velocity? Displacement divided by time. So this is the conclusion for velocity. This slide, we are going to calculate average velocity. For speed, we have calculated the average speed. That was what was the formula for that? The total distance divided by total time. Similarly, we can calculate the average velocity. So what is average velocity? It is the ratio of the total displacement to the total time taken. So what is the formula? Total displacement divided by total time taken. So this gives you the average velocity. So average velocity is also the mean. Mean means the average of the initial velocity u and the final velocity v. So every moving object will have two velocities, one at the beginning and one at the end. So initial velocity, it is kept by the letter u. So another word which expresses u. U is the initial velocity of an object and final velocity is v. V is the final velocity. So how to find the average velocity? The mean of the two, that means the average of the two, initial velocity plus final velocity divided by 2, that means u plus v by 2. So this way also we can calculate the average velocity of an object. Speed and velocity have the same SI unit, meter per seconds. This slide, Here is an example for calculation of average velocity. See to the question. If a car changes its speed from 10 meter per second to 20 meter per second in just 5 seconds, what is the average velocity of the car? Now, what are the quantities given here? Initial velocity and final velocity. That means u and v. So u is taken as 10 meter per second and v is taken as 20 meter per second, and the time taken is 5 seconds. So average velocity is calculated by the formula u plus v, the mean of the two velocities, divided by 2. So 20 plus 30 divided by 2. So it gives you 15 meter per second. Now we are entering into the next new term, acceleration. So first we have seen about speed, then we have seen about velocity. Now we are going to see the new term, acceleration. I told you each physical quantity is expressed by a letter. Now the letter small a is representing the word acceleration. So what is acceleration? Before going into the slide, let me tell you, all of you know to ride your bicycles, right? So when you are about to start your journey on a bicycle, so what do? First you move to a distance, then you sit upon the bicycle and get balance yourself. How is your speed, or in other words velocity, at the beginning? It will be very less, obviously, right? Now what happens after some time? You keep pedaling. When you keep pedaling, what happens to your speed or the velocity? So you are increasing your speed or the velocity by using your muscular force or by pedaling. So your speed changes, isn't it? So whenever there is a change in the speed, we call it as acceleration. So similarly, the same thing happens when the bus is starting. So it slowly picks up its speed, so as your motorcycle. So when there is a change in the speed, we call it as acceleration. Now let us look into the slide. The quantity which specifies change in velocity is acceleration. Now relate to the example which I have told you. How will you define acceleration? It is defined as the rate of change of velocity. A very important definition. Acceleration is defined as the rate of change of velocity. Rate means always referred to unit time. Rate is always referred to unit time. So the rate of change of velocity is referred as acceleration. How to calculate the acceleration? Now acceleration is calculated by the formula final velocity minus initial velocity divided by 2. If the velocity of the body changes from initial value u to final value v in time t, then the acceleration is a is equal to v minus u divided by t, where a represents acceleration, v represents the final velocity, u represents the initial velocity, and so when we do v minus u divided by time, then the quantity that you get is acceleration. And the SI unit of acceleration is meter per second square. Meter per second square, very very important. The definition, the formula and SI unit. These three are very important in acceleration or any physical quantity. Their definition, their formula and the SI unit are very important. Now we are going to discuss a problem on calculation of acceleration. See to this slide. What is the question? A train starts from a railway station. This is a hint. Now we will read the question fully. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. Okay, now a train starting from a railway station. Starting from a railway station means what will be its speed or velocity? So its speed, initial speed or initial velocity is 0. That is what the inference that we get from this sentence. And then it picks up a speed of 40 km per hour in 10 minutes. So how to calculate its acceleration? So what are the informations that we get from the problem? Initial velocity, the letter u, that is equal to 0, and the final velocity, and the letter is v, 40 km per hour. So 40 km per hour has to be changed into meter per second. When you want to convert kilometer per hour into meter per second, just multiply it by 5 by 18. Do you remember this? When you want to convert kilometer per hour into meter per seconds, just multiply it by 5 by 18. So 40 into 5 by 18. So time taken, it is expressed as 10 meters. So I told you earlier, whenever the time is given apart from seconds, it has to be converted to seconds. So since it is given in minutes, so multiply it with 60 so that you will get it in seconds. So 10 into 60, 600 seconds. Now those quantities which are given here has been converted into SI units. So the speed is expressed in meter per second, time is expressed in seconds. Now we can do the calculation using the formula. So the formula for acceleration A is equal to V minus U by T, where V stands for final velocity, U stands for initial velocity, and T stands for second. So substitute here all the V, U and T. Then we get 0.018 meter per second square is the unit of acceleration, as we have seen. So this is how acceleration problems are being solved. So remember the formula, A is equal to V minus U by T, where A is acceleration, V is final velocity, U is initial velocity, and the time is T. Now you have to remember that when the speed or velocity is expressed in kilometer per hour, just multiply it by 5 by 18, you will convert it into meter per second. Now let us sum up all the concepts that we have learned so far. Speed of a body gives us an idea of how slow and fast that body is moving. Speed of a body is equal to distance travelled divided by time taken. V is equal to S by T, where V is the speed, S is the distance travelled, T is the time taken. Average speed. The average speed of a body is the total distance travelled by the body divided by the total time taken to cover the distance. So average speed is equal to total distance divided by total time taken. And uniform speed. A body has uniform speed if it travels equal distance in equal intervals of time, no matter how small these time intervals may be. This slide gives you the 5 major difference between speed and velocity. First point, speed is the distance covered by the body per unit time. Velocity, it is the displacement of the body per unit time. So the definition is the first difference. Second point, speed is a scalar quantity and velocity is a vector quantity. So it has scalar will have only magnitude, vectors will have magnitude as well as direction. Third point, the average speed of a moving body can never be 0. Whereas the average velocity of a moving body can be 0. When the displacement is 0, the velocity will also be 0. Fourth point, speed gives an idea about rapidity of motion of a body. Velocity gives an idea about rapidity as well as position of the body in motion, because it is a vector quantity. Fifth point, speed of a moving body can never be negative. Velocity of a moving body can be positive, negative, or 0 depending on the point of reference. Now we have come to the end of today's learning process, children. So I don't want to force you more. We have discussed only 3 things in this lesson, today's lesson. One is motion, whether it is uniform or non-uniform. Secondly, it is speed and velocity. Thirdly, acceleration. Only 3 things we have touched. So for each of this physical quantity, you must be able to know its definition, SI unit, and the problems to solve it. So for that you must know the formula and the letters by which each of them are being kept with. For example, small a represents acceleration. The distance is represented by the letter. Can you tell it what it is? Yes, it is S. So, and time is kept by the letter T, and initial velocity is kept by the letter U, and final velocity is kept by the letter V. So like this. So make a note of all the letters and paste it on your table. So these letters will help you in finding out the formulas as well as solving the problems. Okay, children? So do revise by repeated listening and send the response as usual you have done with the WhatsApp in the group viewed PPT with audio. So regarding the assignment and classwork and the homework, I will tell you separately. Okay, children? So we will meet next week. Until then, bye bye, children. Keep safe, keep good.